Building upon the developments in the last release, work has continued on improving the performance of Autodesk PowerMill when it comes to calculating toolpaths, and PowerMill 2021 is no exception, with considerable improvements in calculation speed across a number of toolpath types. Improvements in several areas such as slice optimization, the utilization of multi-threading, and processing with stop model and rest boundaries means PowerMill 2021 regularly outperforms PowerMill 2020 on the same tasks. For this example, we will be using a simple forging die for a trackpad, the size of which is 600mm in X by 350mm in Y by 96mm in Z. And in this project we have 8 toolpaths in the setup, 3 of which we will be calculating in this tutorial in order to compare their performance. We will be making a side-by-side comparison between PowerMill 2021 and PowerMill 2020.0. In this instance, both versions have been run independently on the same Lenovo ThinkPad P71 workstation laptop, which has a quad-core Intel Xeon E3 processor, 64GB of RAM, and an NVIDIA Quadro P4000 graphics card. Here we have both versions of PowerMill. Version 2020 is on the left, and version 2021 is on the right. Let's look at the first toolpath. In this case, we will start with an area clearance roughing operation. We will access the settings of the toolpath and go straight to calculating it. We are using a 30mm diameter tool with a 2mm tip radius and an offset all style for this roughing operation. Obviously, in the context of a tutorial, this has to be a relatively simple part, but even with this quick roughing operation there is a difference in calculation times. PowerMill 2020 took 14 seconds to calculate, whereas PowerMill 2021 took just 11 seconds, a saving of 21%. Let's move to the next toolpath, access the settings and start the calculation. This time we have a rest machining operation, which is using a 6mm diameter tool with a 1mm tip radius and is referencing the previous roughing operation through the use of a stock model. We have the same step down value but are reducing the amount of material on the part from 1mm to 0.2mm. As we reach the end of the calculation, PowerMill will warn us that some areas remain unmachined, and this is simply because the tool is a little too large to machine all of the rest material. We can close this message. Again, we can see an improvement in the calculation times, with PowerMill 2020 taking 68 seconds and PowerMill 2021 taking 57 seconds to calculate. Whilst closer, the result still represents a 16% saving in overall calculation time. We'll move to the final uncalculated toolpath, access the settings and calculate. This is another rest machining toolpath, but since we have now added some finishing operations to the outer regions of this forging die, we need to calculate the changes in the stock model. We are using a 2mm ball nose tool and are limiting the toolpath to stay within a rest boundary to tackle most of the remaining material to be roughed. So we must calculate a stock model, rest boundary, and then the toolpath itself. PowerMill will again warn us that some areas remain unmachined, but we can close this message. Once again, PowerMill 2021 leads the way, taking just 44 seconds to process this operation, with PowerMill 2020 taking 67 seconds, representing a 34% time saving. Summarizing the results in this test, we can see an overall improvement of 37 seconds, saving 25% overall, showing that on more complex parts the time savings could be significant. Overall, these improvements in calculation performance will minimize your programming time and help maximize your profitability.